Every time you press the power button, your computer must find millions of tiny pieces of information before anything appears on the screen. Just replacing a single storage device can make the entire machine feel completely different. It boots faster, applications open almost instantly, games load in seconds instead of minutes. Most people assume this improvement comes from a faster processor or more memory, but in reality, the biggest difference often comes from one component: the storage drive. For decades, computers relied on hard disk drives, a remarkable piece of mechanical engineering that stored information on rapidly spinning magnetic platters. Today, solid-state drives have almost completely replaced them, not because they simply spin faster, but because they removed spinning altogether. To understand why an SSD feels dramatically faster, we first need to understand what actually slows a hard drive down. At first glance, a hard disk drive looks surprisingly simple. Hidden inside its metal enclosure are several perfectly polished magnetic platters rotating thousands of times every minute. Floating only a few nanometers above those platters is an incredibly delicate read and write head. Every photo, every document, every operating system file is stored somewhere on those spinning disks. But unlike electronic memory, a hard drive cannot immediately access the data you request. Before anything can be read, the actuator arm must physically move the read head to the correct track. Only then must it wait for the platter itself to rotate until the exact sector passes underneath. Only after both movements are complete can the drive finally begin reading your file. That entire process may take only a few milliseconds. But modern operating systems don't request one file, they request thousands. And every one of those requests repeats the same mechanical sequence. Again, and again, and again. Those tiny delays eventually become the loading screens everyone remembers. The SSD was designed to eliminate every one of those delays. There are no spinning platters, no actuator arms, no read heads floating above a magnetic surface. Inside an SSD, information is stored inside billions of microscopic flash memory cells built directly into silicon. Instead of moving mechanical parts, the drive only moves electrical signals. The moment your computer requests a file, the SSD controller sends an electronic command directly to the memory cells containing that information. No motors need to accelerate. No mechanical arm needs to travel across the disk. No rotating platter needs to line up with the read head. The data begins moving almost immediately. That is why the access latency of an SSD is measured in microseconds, while a hard drive usually needs several milliseconds. It sounds like a small difference, but when thousands of files must be accessed every second, those milliseconds become the biggest performance bottleneck inside an entire computer. Removing moving parts explains part of the speed advantage, but it doesn't explain everything. The real engineering breakthrough is something far more powerful: parallel processing. A hard drive has only one read head working on one location at any given moment. If another piece of data is needed somewhere else, the head must leave its current position, travel across the platter, and start the entire process again. An SSD works very differently. Modern SSDs contain multiple NAND Flash chips connected through several independent memory channels. While one chip is reading data, another can already be writing. A third chip may be preparing the next request, while others continue transferring information simultaneously. Instead of waiting in line, multiple operations happen together. The SSD controller constantly distributes data across these channels, keeping every memory chip busy whenever possible. This parallel architecture is one of the biggest reasons modern NVMe SSDs can deliver transfer speeds measured in gigabytes per second, far beyond what any mechanical hard drive can achieve. At the center of every SSD is a highly specialized processor known as the SSD controller. It is far more than a simple traffic manager. Every piece of information written to the drive passes through this controller first. It decides exactly where each block of data should be stored. It tracks which memory cells have been used, which ones remain available, and which ones are beginning to wear out. Unlike magnetic disks, Flash memory cannot overwrite existing data directly. Before new information can be written, old data must first be erased. Managing this process efficiently is one of the controller's most important jobs. To prevent certain memory cells from wearing out much faster than others, the controller continuously moves data around the drive. This technique is called wear leveling. Its purpose is simple: spread the workload evenly across billions of memory cells, so the entire SSD ages at nearly the same rate. The controller also performs another critical task: error correction. Every time information is written, tiny electrical changes occur inside the flash memory cells. Over many years, those signals can slowly weaken. Without protection, individual bits could eventually become unreadable. To prevent this, the controller constantly checks every block of data using advanced error correction algorithms. If even a tiny error is detected, it can often rebuild the original information before your computer ever notices anything went wrong. This invisible process happens millions of times every day. Most users never realize it is happening, yet it is one of the reasons modern SSDs remain both incredibly fast and remarkably reliable. When comparing an SSD and a hard drive, the differences become impossible to ignore. Imagine your computer starting from completely powered off. A hard drive immediately spins its platters up to full speed. Only then can the actuator arm begin searching for thousands of operating system files scattered across the disk. Every movement, every rotation, adds another tiny delay. Now compare that to an SSD. The controller receives the request, locates the data, and accesses multiple flash chips almost instantly. No waiting for mechanical movement. No rotational delay. Just electronic signals traveling at incredible speed. That is why operating systems boot dramatically faster on SSDs. Applications launch almost immediately. Games spend far less time on loading screens. And copying thousands of small files becomes dramatically more efficient. Performance is only one part of the story. Because SSDs contain no moving mechanical components, they are also much quieter. A hard drive constantly produces vibration, motor noise, and tiny mechanical movements that can eventually wear over time. An SSD produces none of them. It also consumes less electrical power, which helps extend battery life in laptops. Without spinning motors, less energy becomes wasted as heat. Shock resistance is another major advantage. If a laptop is accidentally dropped while a hard drive is operating, the read head can strike the spinning platter, causing permanent physical damage and data loss. An SSD has no spinning surface to crash into. This makes it significantly more durable in portable devices, which is one of the reasons nearly every modern laptop has transitioned away from mechanical storage. Even with all of these advantages, hard drives have not disappeared. In fact, they are still manufactured by the millions every year. Why? Because they continue to offer one advantage that SSDs cannot fully match: cost. A hard drive can store enormous amounts of data at a much lower price per terabyte. For backups, security recordings, cloud storage, and massive data archives, capacity is often more important than speed. That is why many data centers still combine both technologies. Fast SSDs handle the workloads that demand instant access, while high-capacity hard drives store information that is rarely used. Each technology serves a different purpose. So, has the SSD completely replaced the hard drive? Not entirely, but it has completely changed what people expect from a computer. Today, we expect machines to start within seconds, applications to open immediately, games to load almost instantly. Those expectations exist because storage is no longer limited by mechanical motion. Instead, billions of microscopic memory cells respond almost as quickly as electricity itself. A hard drive remains one of the greatest achievements in precision mechanical engineering. An SSD represents a completely different philosophy. Replace moving machinery with pure electronics. Replace waiting with parallel processing. Replace physical motion with intelligent control. The result is not simply a faster storage device. It is one of the most important engineering breakthroughs that transformed modern computing. The next time your computer starts in just a few seconds, remember, it is not the processor you notice first. It is the silent engineering hidden inside your SSD.